Welcome back to Common Core Algebra 2. Today's lesson is 5.3, Summation Notation. Much of your work in this unit will concern adding the terms of a sequence. In order to specify this addition or summarize it, we introduce a new notation known as summation, or sigma notation, that will represent these sums. This notation will also be used later in the course when we want to write formulas used in stats. All right, so sigma notation is basically this funny looking capital E, which is the Greek letter sigma, the capital letter sigma. And basically what this means over here, so I'm looking right here. All right, and if you look right here, you can see how there's an index. The I goes from A to N, so it goes from number, like from 1 to 10. Okay, f of I, that's going to be your term, equals, and then basically they're saying the first term of the sequence plus the second term of the sequence plus the third term of the sequence until you get up to the last term of the sequence, where I is called the index variable, which starts at a value A, ends at the value N, and moves by unit increments, increased by 1 each time. So just like our terms of our sequences, I has to be natural numbers between 1 and whatever the end of the sequence is. All right, so let's look at a couple of examples, because I seriously think that once you see what I'm talking about, everything I said will make sense to you. So this first example, this says evaluate each of the followings. So the word evaluate makes that implication that we're going to come out with a number. All right, so when I equals 3, so just to be clear to start with, when I equals 3 and I equals 4 and I equals 5, because as you can see, I goes from 3 to 5 of 2I. So in this case, this is going to be 2I is 3, and that summation sign means I put a plus between that one and the next term. So this is going to be 2 times 4 plus 2 times 5. And once you add them up, you get 24. I'm not overly concerned about the addition. I feel like that can be kind of implied. Okay, so again, we started with term 3, 4, and 5. Right here, just to recap, is 2I. So whatever I is, we're multiplying it by 2. So here is 2 times 3, 2 times 4, and 2 times 5, because they correspond to what my index is. Moving on to B. Now here we have a few more terms, because K, the index doesn't always have to be denoted by I. Sometimes it can be denoted by another letter. In this case, it's K. So here I'm going to have K is equal to -1, -2, early in the morning, folks. Okay, K equals -1 and getting larger. So -1, 0, 1, 2, and 3. All right, so now it says K squared. So here, this is going to be -1 squared plus 0 squared plus 1 squared plus 2 squared plus 3 squared. So once we do all this, this comes out to be 1 plus 0 plus 1 plus 4 plus 9, and this comes out to be 15. Are you there yet? Are you understanding what's going on? Okay, so again, I'm writing these index numbers out. I'm hoping you get to the point where you don't have to do that anymore. But to start with, I think it might be a good idea. So this J is going to start with J equals to -2, and they're getting larger. So -1, 0, 1, and 2. And what is this saying? This is saying 2 to the index. So when X is when J is -2, you get 2 to the -2 plus 2 to the -1 plus 2 to the 0 plus 2 to the 1 plus 2 to the 2. So this becomes 1/4. This is 1/4 plus 1/2 plus 1 plus 2 plus 4. And you add them all up, and there's actually a few different ways that you can write this. 7 3/4, which I'm not a big fan of. Remember mixed up fractions? All right, as an improper fraction, it's 31/4. Or if you did it in your calculator, you probably come out with 7.75. Okay, so now we're going to move on to D. So if you're feeling confident, you might want to pause the video and give these a try on your own. If you're not feeling confident, then we'll do them together. So again, make sense of this. This is -1 to the index of I. So I know I is starting with 1. So I know this is going to be -1 to the first, plus -1 to the second, plus -1 to the third, plus -1 to the fourth, plus -1 to the fifth. Sorry, I'm kind of intruding on my next example here. So this turns into -1 plus 1, because if you have -1 raised to an even power, that's going to be +1. -1 raised to the third power is -1. This is going to be +1, and this is going to be -1. So if we cancel some of these out, these two cancel, my answer is -1. So taking a look at E, I'm going to just slide down a little bit so I'm not getting in the way of letter D. 0, so I know I'm going to have 2 times 0 plus 1. That's my first term. Plus my second term is 2 times 1 plus 1. That's my, so this is K is 0, K is 1, and I need K is 2. So let's put one more down here. Plus 2 times 2 plus 1. So this becomes 1 plus 2 times 1 is 2, plus 1 is 3, plus 2 times 2 is 4, and 4 plus 1 is 5. So this turns out to be 9. And going on to F, we have 1, 2, and 3. Now again, if it's easier for you to write these out, feel free to. So you know you're going to have 1 times 1 plus 1, plus, that's the first term, 2 times 2 plus 1, there's the second term, plus 3 times 3 plus 1. There's the third term. And I know I'm going to have 3 terms because I start with 1 and go to 3. So 1, 2, 3. So this becomes 2 plus 2 times 3 is 6, plus 3 times 4 is 12. Add them up and you get 20. Alrighty, so now there is a way to calculate these in your calculators, but obviously you don't have them at home. I'm going to show you quickly now so that tomorrow when you come into class, you can check your work using that calculator. All right, so I'm going to open the calculator, go to your calculator icon, and where do we find all of our information? LOL button, lots of list button. All right, so if you look right over here in the middle, all right, and I don't know if I can do this, but right here, this is what I'm looking for. Okay, so let's open that. And there we go. There's our sigma notation. Now you can make your index anything you want. So let's go according to what we're going to use. So let's take a look at one of the more difficult ones, like F. F says I equals 1. So let's use the letter I equals 1, 2, this is what we're doing F, to 3. All right. And now what is this going to look like? It's going to say I, just like it writes, I parentheses I plus 1. End the parenthesis. And I know it looks funny with the 2 sets of parentheses, but that's what it looks like. All right, so make sure you wrote it down the way it looks on your paper and you hit enter. and it's telling me invalid implied multiply. So what's the problem with that? I wonder why it won't let me do that. All right, so so it's saying it's implied multiplied. So what if I do 1 times? Will it let me do it then? There we go. And our answer was 20 for F. So it just goes to show you, you can't do an implied multiply, you have to put time sign between the two of them, which isn't a problem. I learn things on this calculator every day. All right, so being able to check your work using this calculator is amazing. So let's go back to our lesson. Write down what you need to, and then meet me at exercise 2. Which of represents the value? I'm thinking it's supposed to say which of the following represents the value of this summation. So you could put this into your calculator. This is a multiple choice question, so that's the beautiful thing here. But if we're going to do this by hand, I know my index goes from 1 to 4, and it's 1 over I. So I know this is going to be 1 over 1, 1 over 2, 1 over 3, 1 over 4, and this you can put your whole thing into your calculator, or if you did it by hand, looking for my common denominator is 12, gives me 12 plus 6 plus 4 plus 3, which is 25 over 12. And voila, there is my answer. So the answer to this one is 3. Like I said, if I just did it by hand. That's the way I've kind of been brought up doing it. You guys have been brought up doing it in your calculators, so feel free. Don't stress out about fractions. I know they're the F word, but we have a calculator that does it for us. Okay, so here we go on to exercise 3. Consider the sequence defined recursively by a sub n equals a sub n minus 1 plus a sub n minus 2, where a sub 1 equals 0, a sub 2 is equal to 1. So again, let's make sense of this. This is the term we're looking for. This is my previous term. And this is the term before that. So they have to give you 2 terms to begin with, and they do. So we know that a sub 1 is equal to 0. We know that a sub 2 is equal to 1. All right, so can we figure out the rest of them? Because based on this, we need to be able to sum these terms of these sequence. So let's see what they're even looking for here before we start worrying about this sequence. So I'm taking this right here. I'm coming over here. This is going from 4, 5, 6, and 7, and it's telling me it wants to find a sub 4 plus a sub 5 plus a sub 6 plus a sub 7. All right, so we need to find a sub 4, 5, 6, and 7. Now we know what a sub 1 and 2 are. They're right here. So what is a sub 3 based on our sequence here? It's going to be the previous term, which is 1, plus 2 times the term before that. So this is going to be 1. A sub 4 is equal to the previous term, which is 1, plus 2 times the term before that. A sub 2 is 1, so that's 1. So that equals 1 plus 2 is 3. A sub 5 is equal to the previous term, which is 3, plus 2 times the term before that, which is 1. 3 plus 2 is 5. Now, don't get ahead of yourself. This looks like it's generating odd numbers, but make sure you take a look at this, because a sub 6 is the previous term, which is 5, plus 2 times the term before that. 5 times 6 is 11. And the last one we need is a sub 7, which is the previous term plus 2 times the term before that, which is equal to 21. So now using our summation here, I know that I'm going to have 3 plus 5 plus 11 plus 21, which is equal to 40. Okay, so this is kind of a two-step problem. First, you have to figure out what they're asking us with our summation, which we did right here, and then we had to go back and actually generate the sequence that they were asking us to add up together. Okay, write down what you need to. Moving on to exercise 4. It's also good to be able to place sums into sigma notation. All right, so now we're going to be given the series. This is called a series. We're going to be given the series, and they want to write it in sigma notation. So this, I have to tell you, is probably more common sense than anything else. So you have to just kind of figure out what the relationship is to the index numbers, 1, 2, 3, and then whatever this turns out to be. So sigma notation looks like that capital E. I know it looks funny. And use an index. I like using I, but you can use K, you can use J, you can use A. All right, so we have I starts at, and now we have to figure out a way to put these together with our index. Now, the beautiful thing about this is I'm looking at this, and I don't really have anything that relates to 1, 2, and 3 with 9, 16, and 25. But if I really think about it, I can get rid of these and I can replace them with, let's say, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared, and 100 is 10 squared. So I can change my index. I don't have to start at 1. I can start at 3. Or you could even start at 0. So starting at 3, going up to 10. Yeah, I did say earlier that the index has to be natural numbers. No, they need to be integers. You can start with negative numbers as well. All right, so this goes from 3 to 10. So now what am I going to do? I squared, right? So what's that going to give me? Always take a minute and do it. So 3 is 3 squared, which is 9, plus 4 squared, which is 16, plus 5 squared, which is 25. So yes, this is a good representation of the series that was given to me. So now I look here, and the first thing I notice in B is that I seem to have like multiples of 3 here. So that's what I'm going to consider. So what is negative 6? Negative 6 is 3 times negative 2. Negative 3 is 3 times negative 1. 3 to 0 is 3 times 0. So I can see how very nicely my summation is beginning at I equals negative 2, and it's going up to 3 times 5 to 5. And simply, we're going to do 3I. Now, is there another way to do this? Of course there is. We can write this in a couple of different ways. All right, but I like 3I. I always have to try to find the simplest way to do this. All right, but you could actually write this in a different way. Let me see if I can find my notes. I think that this also works. Summation I equals 0 to 7 of negative 6 plus 3I. I don't know who would do that. It seems a whole lot more difficult than what I have, but it also works. So going to C now. Let's see. I know this is 5 to the negative 2. This is 5 to the negative 1. This is 5 to the 0. This is 5 to the 1. I come out with these pretty quickly. I don't know if you will, but I'm hoping you recognize that these numbers are all powers of 5. So this is 5 to the 4th. So this is going to be summation goes, let's use J this time, feel wild and crazy. J goes from 1, I'm sorry, see, I'm feeling wild and crazy and I'm not even doing it right. So where am I starting? At J equals negative 2, and I'm going to go to J is 4 of 5 to the I power. All right, because this is a series plus plus. Now, if that's confusing to you, you might want to stop and take a look at that one more time. or just leave it paused on here and try and figure it out before we move on to the last two exercises. Exercise 5. Which of the following represents the sum of these numbers? Now, could you use your calculator for this? Of course you could. It would take you a little bit longer, but if you were stuck, that is an option for you. But if you take a look at this, we're going to kind of think about this the same way. I look at 3, 6, 12, 24, 48, and I see how they seem to be, 3 times 1, 3 times 2, 3, no, that doesn't work, because 3 times 3 is 9, that's missing. So we have to kind of give this a little bit of thought. So what is this? This is 3 times 1. This is 3 times 2. This is 3 times 4. This is 3 times 8. And this is 3 times 48. No, 3 times 16. Oh, there we go. I can see the pattern now. I have powers of 2. Right? I have 2. This is going to be 3 times 2 to the 0. This is going to be 3 times 2 to the first. This is going to be 3 times 2 to the second. So I find my pattern. So the pattern's going to be, let's use, oh, they use I in our choices, so we have to use I. So I is equal to 0, and it goes up to, this is going to be 3 times, I just said 2, but I'm doing 4. This is 3 to the, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is going to be to the 4th power. So to the 4th of 3 times 2 to the I power. So is that there? It sure is, right here. But like I said, if it doesn't work out the way you want it to, sometimes generating the sequences that you're given is easier than trying to figure out what the summation is from the original series that they give you. Okay? So in other words, what I'm saying is if you had your calculator, you could put all of these into your calculator. You could add these numbers up and see which one of these is equal to that. Okay? And our last problem. Exercise 6. Some sums are more interesting than others. Determine the value of this, show your reasoning. This is called a telescoping series or sum. So even this looks like you're going to have to write out 99 terms, but you're actually not going to have to. All right, and what I mean by that is if we consider doing this, and remember, don't flip out, just start working. Because surprisingly enough, things start working out once you start working. So here I'm going to have, when I is 1, I'm going to have 1 over 1 minus 1 over 2. And then I'm going to add when I is 2, which is 1 over 2 plus 1. I'm sorry, it's minus, not plus. Make sure you're writing that down. 1 over 2 minus 1 over 3. And then the next one is going to be 1 over 3 minus 1 over 4. All right, well, that's making me feel better. I'm kind of understanding how this works. And now I can very easily come up to, I have 99. So the very last term is going to be 1 over 99 minus 1 over 100. All right, what's the term before that going to look like? 1 over 98 minus 1 over 99. Remember, that's a minus sign. All right. So a telescoping series means that when I look at this, you see these two terms here? They cancel out. You see these two terms here? They cancel out. And they'll continue canceling out until we get all the way down here. Do you see these two terms? They cancel out. And then this one would cancel out with the one before it. So what are we left with? We're left with the 1 at the front, and we're left the minus 1 over 100 in the back. And you can put this in your calculator, or I'm hoping you realize 1 is the same thing as 100 over 100 minus 99. I'm sorry, I'm getting to the answer. Minus 1 over 100, which is equal to 99 over 100. So even though some of these look really difficult, the minute you start working them out, all of a sudden they start making sense. So you'll realize the only thing that we have left once everything cancels out is the very first term, which is the 1, and the very last term, which is a negative 1 over 100. Okay? So in class, we will go over the classwork. Please make sure you're getting your videos watched. This is very important. We're in the second half of the year now, and we have to make sure that we are making progress. Okay, our Regents exam is closer than you think. So until then, make good choices, and I'll see you next time.